Yes. When we analyze a problem with circular motion, we always want to choose the coordinates like this. One coordinate along the centripetal direction, another coordinate the coordinate axis along the tangential direction, right? So here we are going to do the same thing here. This is our positive y direction. It's the centripetal direction, C, okay? This is our positive x direction, tangent direction t. Okay. And then let's do the force analysis. And then after that, we can connect them to the circular motion kinematics. Now, how many forces you have for this object at this point? Two. Which two? Tangent t is here. The weight W equals to mg is here, right? Okay? And if we establish coordinates like that, according to the standard procedure, you have to decompose W to get Wy and Wx. Okay. And in this case, you can see this angle is 30 degrees, right? So you can do the decomposition, which will give you Wx equals to positive, okay, in this word is positive, mg, which is the weight, multiplied by sine. And Wy will be negative mg multiplied by cosine. Right? Any question here? And the tension is simple. Tx equals to 0 and Ty equals to T. Okay. Now, I'm going to write down the Newton's second law. So it will become this. X direction, combine the two, so you get mg sine equals to max, right? Okay, together will give you ma. Along y direction, we get negative mg cosine equals to plus t, okay, equals to ma1. Now, you can see that so far I'm just doing the standard procedure of force analysis, writing down the Newton's second law. I'm not even connect this problem, connect these things to the question we're asking here. Okay, but in many cases we can't see through it. We cannot see through the problem from the very beginning. Just do the standard procedure and see now if we can connect this to the problem. Okay? How do we connect this problem to that problem? We are going to ask the centripetal acceleration and the tangential acceleration. Can you see that in this case, ax, the acceleration along this direction, is actually the tangential direction, right? Because at this point, the circular motion is like here. So x direction is along tangential direction. Y direction is along centripetal direction. So we actually have ax equals to at and ay equals to ac, right? So now we connect our standard procedure to this particular problem. Okay. Now, any question here? So, and then you will be the two questions. And after we calculate the two acceleration, then we can calculate the tension. So everything contains in the two equations, right? Newton's second law are the most general equations we can use for all the problems. Okay, so if we put this information in, we get mg sine 30 equals to MAP, which is the second question there. negative mg cosine AC. Okay. Now, but okay, we need to get something else. This equation is okay. This equation we can directly calculate A sub t, the tangential acceleration. Okay, there is nothing tricky here. But for this problem, we need to calculate both the tension T and the centripetal acceleration. Okay? So, one equation cannot do that. So we have to find some way to calculate either T or AC at first. So, do we have any equation can do that work? Which quantity can be directly calculated without looking at the Newton's second law? AC, by definition. Okay, so the first thing, by definition, what's AC? V squared over R, and we do give you the velocity at that point, right? At that point, velocity equals to, what's that? 4. And do we know the radius? The radius, of course, is the length of the pendulum, right? So it's equal to 2 meters. So this is calculable, okay? So Q squared, or 4 squared, divided by Q, H meter per second squared. And then the tangential acceleration AT can be calculated from this equation. So part B, you can cancel M here. So you get G sine 30 equals to A sub T. So it equals to 10 times, what is sine 30? 1/10, right? Equals to AT, equals to 5 meter per second. So this is the tangential acceleration. Okay? And then, to calculate the tension T, we only need to use that equation M negative mg cosine plus T equals to MAC. So you get T equals to MAC plus mg cosine. So it equals to, what is the mass? 1.5 times H. AC, right? We just calculate H plus 1.5 times 10 times cosine 30 degrees. So you can get the tension. Any question here?
Going back to part B, tangential acceleration, where you pick that up on
Okay. Now, by the way, since, okay, here, if I'm asking you, here we calculate the centripetal acceleration and tangential acceleration. If I'm asking you what is the total acceleration, how do you calculate it? Just combine the two by this one and this one by Pythagorean theorem, right? By definition. Now, do you have any question here? For calculation, or go to the discussion. Now, okay, we try to discuss this. How does the centripetal acceleration, tangential acceleration, and the tension with three quantities change during the motion from the releasing point to the lowest point? Okay, so from the releasing point to the lowest point, how does these three? So let's look at, okay, first, centripetal acceleration. Should it be increasing or decreasing? Okay, how do you know that? By definition, the centripetal acceleration is determined by the velocity. And you know, when you release the pendulum, the velocity of the pendulum getting larger and larger, right? So the velocity is increasing, centripetal acceleration increasing. Okay. So each equation can give you the calculation and can also tell you how these quantities change with another quantity. So if acceleration changes and increase, thus the centripetal acceleration increases. Okay? Any question here? Because it's proportional to v squared. Now, how about the tangential acceleration? Should it be increasing or decreasing? Okay, let's check. Tangential acceleration. Yes, decreasing. How do you know that? Look at this expression. So the tangential acceleration is proportional to sine theta. Okay. When you're releasing the angle, when you're releasing the pendulum, okay. So the angle will decrease or increase.
Decrease.
The angle will decrease and sine will decrease or increase. Decrease. Okay. From 0 to 90 degrees, sine is increased with the increasing angle, decreasing with the decreasing angle, right? Okay. Sine 0 equals 0 degree equals to 0. Sine 90 degree equals to 1. So if the angle decreases, sine decreases. If the sine angle decreases, how about the acceleration? Decreases. And then, how about the tension?
Increases.
Look at here, okay? From those equations, should it increase or decrease?
Increase.
Yes, it's increase. Okay, let's analyze this. In fact, it's determined by this and this. First, if we look at the first term, this is increase, right? We already determined the acceleration will increase, right? So the contribution from this term will increase the tension. And how about this one? Itself wouldn't just be some tool for you to do the calculation. The most important thing, all the equations are some function. Okay, so it tells you how one quantity depends on another quantity. Like in the most simple case, if A equals to V squared over R, so that means if you increase V, A will increase. If you increase R, A will decrease. Okay. So all the equations that will help us to discover a lot of things. Okay? So that's all the problem we're going to discuss today.